The topic of the video and technique under study is FTIR. For its name, it is abbreviated for Fourier Transform Infrared Spectroscopy. From the name, it is clear that it is a spectroscopic technique but somewhat different from the traditional spectroscopy. Basically, FTIR is a technique used for chemical characterization of the materials up to the molecular level. Functionally, FTIR uses IR rays of electromagnetic region from the wave number ranges from 400 to 4000 cm inverse. FTIR obtains infrared spectrum of absorption, emission, and photoconductivity of solid, liquid. Basically, it measures the amount of light absorbed by the sample at each wave number. Talking about its working principle, the intensity of infrared rays are enough to produce molecular vibrations in the sample, hence it is also called vibrational spectroscopy. The difference between the FTIR and traditional spectroscopy is such that it does not measure each frequency individually but collectively. It is more fast, simple, and precise than traditional spectroscopy. If we talk about its apparatus, FTIR consists of a source that originates electromagnetic radiations, signal sorter, which is a kind of a dispersion and interference device used for resolving frequencies, sample compartment, signal detector, and a computer for data analysis. The objective of this video is to become familiar with infrared peak of sample and to be able to use FTIR to identify unknown sample. In this video, two types of FTIR techniques, that are transmission FTIR and ATR, is being used to demonstrate the sample characterization.
The background spectrum is obtained by placing the sample holder in the instrument. We assure that the infrared beam is passing through it. After assuring, close the lid of the instrument. Start the Spectra Manager software, which is already installed in the system. Click on the option Spectra Measurement. It will initialize the instrument and the software will start preparing for diagnosis. It will take a few moments to initialize the instrument and the software. Click on the options parameter. Scans will be 32. The range will be from 4000 to 600 per centimeter. After the parameters are set, click on the background for obtaining the spectrum of reference. The loading is shown in the green color below.
Wait a minute!
Obtaining the sample spectrum, fix the sample in the sample holder. Next, adjust the sample with the sample holder in the instrument carefully and assure that the beam is passing through it. After adjusting, close the instrument. Click on the option Sample for obtaining the sample spectrum. The loading is shown below in green color.
A few moments later.
The obtained sample spectrum will be opened in a new window. As the window is opened, now we will adjust the spectrum according to our needs. For that, select the option Processing from the tab. Select Smoothing from the list. Now select the baseline from the same option and mark the baseline to 100.
Another setup for solid sample in FTIR is a 20 total reflectance. The sides are adjusted, in between them the rays are passing from sample towards detector. ATR has a pressure clamp which screws down to press the sample. Now air is being taken as a reference. The FTIR is controlled by a computer software. To obtain spectrum in lab, the FTIR computer should be running with the spectrum measurement screen. As we are firstly taking air as a reference, so as to obtain reference peaks, from the Measure tab, select Parameters. Scans are set to 32 and the wave range is from 4000 to 600 per centimeter. Press OK. Select the B in the tab until the graph is shown. The graph has been shown on the screen, and below the software is scanning the graph 32 times as adjusted by us in the parameters. Wait until scans are completed.
A few moments later.
Scans are completed. Now this is the background reference graph for air. Now we are placing our rubber sample in between the screw and diamond crystal to observe its spectrum. The spectrum has been obtained. Once the sample has been scanned, we need to wait until number of scans have been done.
One eternity later.
We need to label peaks and print our spectrum so that we may see our IR spectrum in the spectrum analysis window of the software. Open the new tab. Go to the top of screen under processing and scroll down to IR options. Here go to the auto baseline. The order is selected to true and applied. Now the peaks need to be smoothed. For that, go to processing and then in corrections, select smoothing. Values are auto selected, just apply and OK. Now go to processing, peak processing and then peak find. Here the upper limit is set to 100 and the lower limit is applied to 0. The data will be shown on the left side. Press OK to return to the spectral analysis window and see that the peaks have been assigned positions.
Now, after the experimental procedures are performed, we will now be looking forward for the discussion of obtained graphs and identify the sample by studying one of the graph. So, let's start. And the first is the graph obtained by the transmission FTIR, having so many complex peaks. And then the graph obtained by attenuated total reflection ATR FTIR, having simple peaks with obtained value. Since the transmission graph have no peaks values and ATR has values, so it is easy to study the ATR graph. So let us begin with the study of ATR graphs. Before the study, we should know that the total graph is divided into two regions. The first is functional group region and other is fingerprint region. Fingerprint region is quite complex, having so many peaks. So then let us start with the functional group region. The first value of the functional group region is 3294.79, identifying the zone 1 presence of the peak in FTIR graph. Hence, it is known as the alkyl present or terminal alkyls. The second is two values equally obtained, known as the CH stretches obtained in our compound or present in a compound. The second values are the pair of 1655.59 and 1443.46, denoting the presence of benzene ring of double bond presence in our compound. So the total values accumulated, the best perfect performance is known as the SBR. The presence of the compound is called SBR styrene butadiene rubber, having alkanes, stretched alkanes and benzene rings.